In this video, through a solved example, let's try and understand how to price a bond in between two coupon dates. Now, when it comes to bonds, please note that the price that you actually pay when you buy a bond may not be equal to the quoted price. The price that you pay is called the invoice price, also called the full price, or let's say the dirty price. This is the price which is arrived at as the present value of all future cash flows of this bond. And future cash flows, we know, include both coupons as well as the final principal or face value. Now, if let's say you are in the middle of, or let's say in between, somewhere in between two coupon dates, another concept that comes in the picture is this concept of accrued interest. Think of accrued interest to be the portion of the upcoming coupon that has already been accrued. So let's say if you are standing as of a certain point in time, let's call it the settlement date, the accrued interest is very simply the number of days since the previous coupon divided by the number of days in between the current coupon period. This ratio times the dollar coupon amount that you are expected to receive on the upcoming coupon date. Okay, now this is your dirty price, this is your accrued interest. The quoted price in the market, also called the flat price or the clean price, is simply equal to the dirty price, which was this one, minus the accrued interest. Okay, now let's come back to the solved example that we have to do in this video. So let's say I want to price a coupon bond which pays an annualized coupon of 6%. These coupons, they are paid twice every year. They are paid on 15th of May and 15th of November. Then the day count convention that we will be following is 30/360. The current date, let's call it the settlement date, is 17th July 2020, and the maturity of this bond is 15th May 2022, so 2022. Okay, the annualized yield to maturity of this bond, YTM, is given to be as 4%. Think of this 4% to be semi-annually compounded. Okay, now let's do this. Let's begin with calculation of accrued interest. So this was my previous coupon date. This is the date as of which I am currently standing, my settlement date, and this is my next coupon date. My previous coupon date was 15th May 2020. My current date is 17th July 2020, and my next coupon date is 15th November 2020. So since I am following 30/360 day count convention, and since these two dates are 6 months apart, and in 30/360 every month is 30 days, this tells me that the total number of days in this coupon period is 180 days. Okay, now let's do this. Let's use the date functionality in our financial calculator, and let's try and find out what is the number of days between these 2 days, and then therefore the number of days between these 2 days. Okay, so if I were to go to my financial calculator and turn on the date functionality, it's located right here. So second, and then press 1. This is my date functionality. Enter the first date, which is 15th May 2020. So I am using the Europe convention, and hence the day comes first and then comes the month. So I'll enter the date as 15.0520 and press enter. This is my date 1. Press the down arrow, enter your date 2, which is the settlement date, and that is 17th July 2020. So entered as 17.0720. Press enter. This is your date 2. Press the down arrow, and then before I compute the days between dates, let me confirm the day count convention which my calculator is using. So it is indeed using the 30/360 day count convention. Okay, so come back up, compute the days between these two dates, and it comes out to 62. Okay, so I'm saying that the number of days since the last coupon date is 62. This tells me that 180 minus 62, which is 118, is the number of days till the next or upcoming coupon date. Okay, so accrued interest would very simply be equal to 62 days which have elapsed since the last coupon was paid, divided by the total number of days in this coupon period, which is 180, that times the dollar amount of this coupon, which is $3. Why so? Because my face value is 100. I get the coupon every 6 months, so 100 times 0.5, and that times the annualized coupon rate, which is 6%. So 100 times 0.5 times 6% gives you $3. Okay, so you can check this, that the accrued interest, it comes to 1.0333. Okay, this is my accrued interest. Now let's do this. Let's try and now calculate the invoice price, or let's say the full or dirty price of this bond. So what I'll do is that I will calculate this dirty price using 4 different approaches. And what you can do is that you can pick any of these 4 depending on which one you are more comfortable with. Now, the first approach is the brute force approach. We don't really use the TVM functionality in our calculator. We assume we don't even have a financial calculator. We basically use, let's say, a scientific calculator, and we find the full, or let's say the dirty price of this bond by simply discounting all the future cash flows to today. Okay, by multiplying each of these cash flows by an appropriate discount factor for the date as of which this cash flow is paid out. Okay, so if I am standing as of this point in time, okay, so this is 17 July 2020, how many cash flows are still left in this bond? There are actually 4 cash flows left. 1, 2, 3 and 4. Okay, so I have also written down the dates as of which each of these cash flows will be paid out. Just note that the last cash flow includes the face value as well, and hence it is $103. Okay, now when I try and calculate the theoretical price of the bond by discounting all these future cash flows, the first thing which I have to note here is that since I am in the middle of 2 coupons, the number of periods till each of these cash flows is not a whole number. Okay, so I'll be dealing with fractions in my exponents when I write down my discount factors. For the upcoming cash flow, which is this guy, what should my discount factor look like? So this is what I have done here. See, this is my upcoming cash flow. My discount factor for this cash flow is very simply 1 over 1 plus 4% divided by 2. So 1.02 raised to the power of number of periods till I receive this cash flow. And the number of periods is very simply number of days, which if you remember was 118, divided by the total length of this period in days, which is 180. So 118 over 180 gives me 0.6556. Okay, so for the upcoming cash flow, which is this guy, the discount factor is 1 over 1.02 raised to the power 0.6556. For this cash flow, the discount factor will be 1 over 1.02, this time raised to the power 0.6556 plus 1, so that's 1.6556. You can see this here, right? Then for the next cash flow, the exponent is 2.6556. For the last cash flow, which is 103, the exponent is 3.6556. So you can check this using your calculator that this comes to 104.5182. Okay, so if I were to take this 104.5182 and from it subtract the accrued interest of 1.0333, I get the clean price to be 103.4849. Okay, now this is when you didn't even have your financial calculator with you and you wanted to use your scientific calculator. Now this method, this approach is not really worthwhile if, let's say, the number of coupons remaining in your bond is actually quite large. So in that case, let's come back to using the TVM functionality of our financial calculator. Now, the problem with this particular example when it comes to using the TVM functionality is that in this example, the number of periods up until any given cash flow is not a whole number. It's not an integer, right? So if I were to write down the expression for the value of this bond using approach number 1, this is what my expression looked like, right? Now, can I make the right hand side of this expression such that the exponents in the denominator, they become whole numbers? One way I can do this is by taking 1 over 1.02 raised to the power 0.6556 common, okay? And this is then what I'll get. 1 over 1.02 to the power 0.6556 times this guy. Now take a look at this expression in the square brackets. What does this expression tell you? This expression tells me that actually it looks like the fair value, the theoretical price of this bond, had I been standing, let's say, at this point in time on my cash flow diagram. I'm talking about a point in time which is just before the payment of the $3 that the bond pays on 15th November 2020. Okay, I'm assuming I'm standing right, let's say, on the morning of 15th November 2020 when this $3 has not been paid out. Okay, so the value of this bond as of that morning of 15th November 2020 would indeed be this expression that we have written in the square bracket. Okay, so this approach number 2, is kind of telling me that I can find the fair price of my bond as of today, which is 17 July 2020, by following a 2-step process. In step 1, I can find what my bond will be worth on the morning of 15 November 2020, and then in my second step, discount the value of my bond on the morning of 15 November 2020 by multiplying it with an appropriate discount factor. Okay, so step number 1 is to calculate the aggregate value as of this point in time. Step number 2 is to further discount this aggregate value and find the value as of today. Okay, so to find this expression, to calculate this expression in the square brackets, again, let's go back to our financial calculator. Let's place ourselves on the morning of 15 November 2020. Let's take a look at what are the future cash flows that are still left in this bond. There will be 3 cash flows, so n is equal to 3. My yield is 4%, that means on a per period basis it is 2. Then the payment which I receive every period is $3. The face value is $100. Okay, so let's calculate the present value for this stream of cash flows. It comes to 102.8839. Let's remove the minus sign and include in it the $3 which get paid on 15 November 2020. So this tells me that the total value is 105.8839. So this is as of the morning of 15 November 2020. So 105.8839. Okay, so take this value, discount it again using 2% as your, let's say, 6 monthly discount rate, and also using an appropriate exponent. In this case, it will be 0.6556. You can check that again, you get the price to be 104.5182, the same price which we got from approach 1. Now, let's come to approach 3. Again, I have started with the same expression which I had in my approach 1, which is this expression, and to make the exponents, the powers, whole numbers, I'm using a slightly different trick. Let's do this. Let's multiply and divide by 1.02 to the power 0.344. Okay, multiply and divide by the same amount. If, let's say, now I were to take each of these denominators, this guy, this guy, this guy, and so on, and multiply with 1.02 to the power 0.3444, I will indeed now create integral or integer exponents or powers. 1.02 to the power 0.6556 times 1.02 to the power 0.3444 gives me 1.02. 1.02 to the power 1.6556 times 1.02 to the power 0.3444 gives me 1.02 to the power 2, and so on. Okay, now again do this. Take a look at the expression in the square brackets and connect it with our cash flow diagram. Take a look at this guy, right? This is the present value of 4 future cash flows. I can actually think of this expression in the square bracket to be the value of my bond on the evening of 15th May 2020, the previous coupon date. When I say evening, basically I'm saying that the coupon which was meant to be paid on this day has already been paid out. So I'm not including the value of this coupon in this expression in the square brackets. Right? That's why I'm saying evening. Okay. So in this method, again, I am following a 2-step process. In step 1, I am calculating the total value, the theoretical value of this bond as of the evening of 15th May 2020, which was my previous coupon date. That's my step 1. And in step 2, I am multiplying that value by a capitalization factor appropriate for this period, and therefore bringing that value to today, my settlement date, which is 17 July 2020. Okay, so let's do this. Let's use again the TVM functionality to calculate this expression in the square brackets. Now, we have already fed the right inputs into our TVM functionality. Let's just change the number of periods. So let's set n to be equal to 4, recompute the PV. It comes to 103.8077. Let's note it down. So 103.8077. Okay, so this multiplied by the capitalization factor for this period, which is essentially 1.02 to the power 0.3444, which is sitting here. Right? Remember, we had multiplied and divided by this amount, right? So it is still sitting outside. So let's just multiply by 1.02 to the power 0.3444, and you can check this, that again the fair value comes to 104.5182. Okay, this is my approach number 3. Now approach number 4 is to use a very standard functionality which is available in your financial calculator to straight away price a bond. So if you are well versed with the 3 approaches that we've done, and if you understand clearly how the functionality of pricing a bond works in your calculator, approach 4 should be your favored approach. It's the quickest actually. Okay, so my bond functionality is available as a second function in this number 9. So second and then number 9. So start with entering your settlement date. I've already entered this date, 17th July 2020. Then next enter your coupon. Please be aware that this coupon has to be the annualized coupon in percentage terms, and hence I have entered 6. Next, enter the redemption date, the maturity date, and I have entered 15th May 2022. Okay. Then next, enter your redemption value. So this is $100. And then next, confirm your day count convention. It is 360. Next, confirm the number of coupons in every year. So it's 2 coupons every year. And then next, enter your yield, which is 4%. And then next, calculate the price. So when you reach this entry, just press compute and it will tell you the price. The price that it gives to you, please note, is the clean price, the quoted price. And indeed, it's giving you the same amount which we have calculated using the 3 approaches, 103.4849. If you go further down, it also gives you the accrued interest, 1.0333. Okay, so it's a very neat functionality which your calculator already has. It gives you both the clean price as well as the accrued interest. Okay, so this video was about understanding how to calculate the price of a bond in between two coupon dates, how to calculate the accrued interest, how to calculate the full or the invoice price, and from these two quantities, how to calculate the clean / the quoted price.